Hello and welcome. My name is Hugo, and in this video I'm going to show you how to create a bitmap image file using C++. Before I start coding, I just have a quick disclaimer. The purpose of this video is not to make you a bitmap image expert, it's simply to show you how you can export an image in the simplest way possible without using any third-party libraries. You can always expand on this code and add more features and optimizations, but this video will only cover the absolute basics. I've already created a new project in Visual Studio 2019, and I've named it BMP Tutorial, but you can obviously name it whatever you want. Now I'm adding a new class, and I will call it Image, because it's going to represent an image. And I'm also adding a new struct, which I will call Color, and that will represent the color of a specific pixel. I'm creating three floats, R, G, and B, and these will be the color channels. You can use other formats, but using floating point values is pretty common, so I will use that. Then I'm adding a default constructor and a constructor that takes in the different channels. And I will end by creating a destructor as well. Now in the image class, I will create a public section and create a constructor. And this one will take in an int width and int height, and these will be the width and the height of the image. And I will also create a destructor. Now I'm gonna add two more methods, one that gets the color of a specific pixel, and that will take in an x and a y value and return a color, and I will mark that as const. And for the set color method, it will take in a const color reference and an int x and int y. So that will set the color of a specific pixel. And now for the final method, I will call it export, and this is the method in which we are actually going to create the file. I will take in a const char pointer, so a C string, with the path that we want to export it to. And now in a private section, I'm going to create two member variables for the width and the height, and one final std vector to store the colors. So we'll create a new std vector of color and call it mColors. And to use std vector, we obviously have to include vector. You can also mark the export method as const if you want to. Now I will go ahead and create the definition of all of these methods. And that will be done in just a second. And there we go. So now for the definitions. For the default constructor of the color, I will just initialize all of the fields to 0. So R will be 0, G 0, and B 0. For the second constructor, I will initialize the color channels to the parameters, just as expected. And for the destructor, it doesn't really have to do anything because we're not allocating anything on the heap. For the image constructor, we are first going to initialize the width and the height in the exact same way. And we will also initialize the color vector to a std vector of color, and we will set the initial size of that to width times height, because that's how many pixels we will have. The destructor doesn't have to do anything again. So in the get_color method, we are going to return mColors at y times mwidth plus x. And the reason why we have y times mwidth is because we read from left to right and then jump up a row. So y will indicate how many rows up we are. And for every row, there is m width amount of pixels. Now for the setColor method, it will be a pretty similar thing. We are gonna access the color from the std vector once again at white times m width plus x. And we will set the R component of that to the parameter color.r. And we will repeat that 2 times for the green channel and the blue channel. And now for the export method. Before we start writing anything there, we need to include 2 more things. So we're going to go up here and include IOStream because we want some feedback if things are working. And I'm also going to include fstream because that's what we're going to use to export the file. You can obviously use something else, but in this tutorial I'm going to use fstream. So we're going to create a new std offstream, and I will call that f. Then we will try to open the specified path. So we're going to say f.open, and that will take in the path and what we want to do with the file. And we're going to write out and binary, and we can combine these with the bitwise OR operator. So the out means that we're gonna be writing a file, and binary means that we're gonna be writing in binary. Now after that, we have to check if the opening was successful. So if we could create the file or write over it. So we're gonna try if f.isOpen, and if that's not the case, then we will print out a message saying that the file could not be opened. And that's just so that we get some feedback. You don't technically have to do this, but it is a good practice to always make sure that we print something when things go wrong. And then if that's the case, we can also just return. There are 3 required parts to every bitmap image. First, we have the file header, which provides general information about the file. Then we have the information header, or sometimes the DIB header, which provides more detailed information. And lastly, we have the pixel array, which is the color data for each pixel. Now, these parts are what is required, but you can also have more parts in more complicated images. But these are the ones that we're going to use. There's also a detail to the color array, that is that every row must occupy an amount of memory that can be divided into chunks of 4 bytes. If we take an example with an image of width 3 and height 4, you can see that there's space at the end of each row. That's because the colors are specified using 3 bytes, 1 for each color channel, and 3 times 3 is 9, which is not divisible by 4. So we have a problem. The solution to this is to add a bit of padding at the end of each row. The padding is just a few bytes set to 0, and we can calculate how much padding is required by taking the number of bytes that the colors occupy divided by 4, and then we take the rest, and that will tell us how many bytes over the last 4 byte chunk we are. Then we can take 4 and subtract that byte that we are over, and that will give us how many bytes we have left, and in other words, how much padding that we need. So back to the coding now. We are first going to create an unsigned char array, and I will call that BMP pad. This will be of size 3, since we can never have more than 3 bytes of padding. And I will just initialize that to 0. Next, I will calculate how many bytes of padding that we are going to need on each row. And that will be calculated using the formula that I just showed. So 4 minus m width times 3, and then the rest of that divided by 4, and once again the rest of that divided by 4. Now this is a bit confusing, but I will try to explain it. So the width times 3 is how many bytes the colors occupy, because there's 3 bytes for every color. Then divided by 4 and take the rest, says how many bytes over that we are, and 4 minus that gives us how many bytes we have left. But if that turns out to be 0, then 4 minus 0 is 4, which we don't want. So we're gonna divide it by 4 once again and take the rest of that. And that will just make it so that if we have 4 bytes, then it's gonna be dropped down to 0. Next, I will create a constant and I will call it file header size. And that will always be 14. The file header is 14 bytes. Then the same thing for the information header, and that will be 40 bytes. So we're always going to have an information header with 40 bytes. And the last thing is the file size, and that's going to be the entire size of the file. So we're going to have the file header size plus information header size plus the width times the height times 3, which is all of the color data, plus the padding amount, and then times the amount of rows that we have. So that would be m height. And just as explained, this is the actual color data, and the padding is for every row. Now I'm actually going to paste a lot of code, but don't worry, I will go through it, because it is quite a lot of information. So first we're going to create another unsigned char array, and the reason why we're using unsigned char is because it makes the most sense when using binary to me. We're going to set the file header size to the file header size, and the first 2 bytes are always going to be B and M, the ASCII code for these, and that just indicates that there is a bitmap image. Next we have the file size, and that's the one that we calculated just. But since the file size is an integer and we're using unsigned char, and I can demonstrate that just by mousing over these, it will actually have to be divided up. So you can see unsigned char is what we're writing to, and it's an int. So to be able to use bigger values, we have to split it up. Now the next 4 bytes are not used, they're reserved for whatever reason. Then we have the pixel data offset, which is just the headers combined, and that will not exceed 255, so we don't have to bit shift that anything. Next we're creating the information header, and we're setting the size to the information header size. The first byte will be the size of the image header, which once again will not exceed 255, so we don't have to bit shift that even though it is an integer. Then the next 4 bytes will be the width, which once again is an int, and this one have to be divided up into the 4 bytes, as that can be bigger than 255. Then we do the exact same thing with the height, and we divided up that. The planes is just going to be 1, so we set it just like that. Bits per pixel will be 24, and the reason is that every byte is 8 bits, and even though we're using float, we are gonna convert that to a byte. So it's gonna be a value between 0 and 255. The next one is for compression, which we will not use, so just skip that. And the next 4 bytes, once again. The x pixels per meter we will not be specifying because it's not really relevant, and neither is the y. Then the total colors is when using color palettes, which we will not talk about, and the last 4 bytes are generally ignored, so we're gonna do that as well. Lastly, we just have to write these arrays to the file. Now, the fwrite method actually takes in a char pointer and not unsigned char pointer. So we have to use the Reinterpret cast to convert that. That would just use the exact same data, but interpret this as if it was a char array. Next, we need to loops through all of the different pixels. So we're gonna say for int y equals 0, y is less than height, y plus plus. So we just increment for each pixel. And then we're gonna do the same thing for the x values. So the first one is for the rows, and this one is for the columns. So now next, we're gonna create an unsigned char, and we're gonna call it R, and that will represent the red channel of the color that we're looking at right now. So we're gonna get the color at x and y and take the R channel. But this is a floating point, so we have to multiply it by 255, because that will make it in a range of 0 to 255, which is exactly what we want. But this cannot be converted automatically, so we have to use a static cast for that. And the difference with static cast, if you're not used to using them, is just that this actually keeps the value and changes the type. Reinterpret cast doesn't modify the data in any way, it just interprets this as a different kind of data. Then we repeat that for the green channel and the blue channel as well. And now we have the converted colors. So next we are gonna create an unsigned char array that we're gonna call color, and this would just be all of the unsigned chars that we created, but in an array. And because of the way that bitmap images work, we actually have to start with the B component, then the G, and then lastly the R, which is opposite to what you usually see, but that's how they work. And then we're just gonna write that to the file. So we're once again gonna reinterpret the data, and we are gonna write the color, and that's 3 bytes. Now for every row, as I mentioned, we need to add the padding as well. So we're gonna do the exact same thing with the BMP pad and write that to the file. And the number of bytes that we're gonna write will be the padding amount that we calculated earlier. And this will just add the padding after each row. Now the last thing that we need to do is just to close the off stream. And then we can print out a message saying that the file could be created, because we are now done with this entire method. And there we go. So now the final thing that we have to do is just to test this system. So we're gonna get rid of this junk from earlier, and we are gonna create an int width, and I'm gonna set that to 640. That can obviously be whatever you want, and the height I'm gonna set to 480. Then we are gonna create an image using these width and height parameters, and we have to include that image file. Next, we can just delete this old import, and I will create some random image. So once again, I'm gonna loop through all of the pixels. So first the y values, so int y equals 0, y is less than height, y plus plus, and do the exact same thing for the x. So this would just go through the entire image. Then we can use the setColor method in the image class to set the color to some random value. Now, I don't mean random specifically, but this will create a random looking image with just different colors in each corners. And then, yeah, you can look at the code in more detail if you want to know exactly what it does. So lastly, we can just use the export method, and I'm gonna specify the path image.bmp. And I think that would be in the solution directory or in the project. It depends a bit on how you've set up the project, but for me it will be in the solution directory. So now we can just build the program and run it, and it does say that a file has been created. So now I'm gonna go into that directory and I will open the image. And as you can see, it has worked and we have a nicely generated image. So that's it. Thank you so much for watching this. I hope it was helpful. And if you have any questions, just type them down in the comments and I will try to answer them as well as I can. So thank you so much, and I'll see you.